Right, this is question number 6 from the practice set 1 of the Unit 3 Higher papers produced by AQA. Just going to move this piece of paper up a little bit. It says, complete the table for the quadratic equation y equals x squared plus 2x for the x values from -4 to 3. Now, I'm going to start off choosing the positive of these two missing numbers because I quite like to work with positive numbers. So I'm going to work out the number that goes in there. I've got to use the formula y equals x squared plus 2 lots of x, and what I've done is just substituted 3 for x in that formula. If you literally type that on your calculator, you will get 9 plus 6, which is 15. And that will be the first of your 2 marks available for that question. The second of the 2 marks is this number in here, and you can use a similar method. You can do -3 squared, remember to put the brackets in on your calculator, and 2 lots of -3, and you will get the answer 3 in that box. But there is a slightly easier way to do that, or certainly a way to check. And this is the way to do it. You know that this graph is going to be a quadratic graph. It says x squared plus 2x. It's going to be that parabolic shape, either a happy graph or a sad graph. And the thing about those graphs is that they are always symmetrical. So if you can look at the numbers and find some symmetry, so 0, 0, 3, 3, 8, 8, that is a way that you can check or indeed fill in this number here. If you've spotted that there are 2 8s and 2 zeros, and in between there should be 3s to make it symmetrical. Anyway, 2 options there. The second part of the question asks us then to plot those points. So all you need to do for this bit is simply use the numbers from the table above to plot the points. So the first one says x is -4 and y is 8. So we're going to go along to -4 and up to 8 and put a cross. The next one says -3 is the x value and 3 is the y value. The next one says -2, 0, and then it's -1, -1. Take care to read the scale for those odd numbers. 0, 0, 1, 3, 2, 8, and 3, 15. Okay, now what I suggest you do in order to link these up with a nice smooth line, remember there are certain rules. You mustn't have any jaggedy bits like that. They call that feathering sometimes. You mustn't put a flat bottom on your graph, that won't work, and you mustn't miss any of the points which you've put on there. If you do any of those things, you're going to get marked down. So you need to have those points in the correct place. What I suggest that you do is that you turn your piece of paper sideways, like that, and you start here and you just go smoothly down to the bottom there, trying to make it just reach flat on the bottom there. And then I would turn my piece of paper around again so that it's now upside down, and I would start to come back. And I would do this in pencil. I'm doing it in pen for you so you can see, so that I could rub it out. Okay, and if I bring that back to the right way around, you can see that's a nice smooth line passing through every point. If I have made a mistake here, I've not quite gone through that point there. You would rub that out with a rubber and just do that last bit again. Okay, the final part of this question now says, use the graph to find the value of y when x equals 1.5. Now, what that means is find x equals 1.5 on the x-axis and read off what coordinate that would have on the y-axis. So you're literally treating this like a scatter graph or a line of best fit, going up to the line and across to find out what the value is. And in this case, we've got 4, and then there are 3 small squares going up. Now that means it's going to be 5.2. And the reason is that every small square is worth 0.4. 5 squares are 2 units. 1 square is 0.4 units. And therefore those 3 squares, 0.4 each. So you get 4.4, 4.8, 5.2 is the answer we are looking for. 5.2.